Hello and welcome to our next section, proving parallel lines. This time we don't know that the lines are parallel. Get this title into your table of contents. But yeah, like I said, we don't know that the lines are parallel this time, so we're going to prove that they are parallel. So proving parallel lines, 3-2, we're taking a step back and we're going backwards a little bit into our book. Just because the order of this probably makes a little more sense, at least to me it does. So notice this isn't pink, you do not have to copy this down. This is from our last section. If parallel lines and corresponding angles are congruent, this is something we know. If you are given the parallel lines, then you could assume corresponding parts are congruent, or corresponding angles. And we are going to draw a diagram. So definitely get a line across. We're going to draw a set of lines that look to be parallel, but we don't have markings on it. We need to prove that they are parallel this time around. I'm going to call this one, let's close this out. We don't need that. I'm going to call this, let's call this T again for the transversal. Let's call this I, and let's call this S. Now, if we have parallel lines and corresponding angles are congruent, we know that to be true. What if I asked you for the converse of this? What the converse of this is normally P then Q. So what if I switch this around? Oops, Q then P. What would that read? Well, that would read if corresponding angles are congruent, then parallel lines. Oops. Let's draw them vertically. They just look nicer. Then vertical lines. And what if I told you this is true? Okay, so what if I, for instance, put some angles here. Do them blue again. 1, 2, 3, 4, 5, 6, 7, and 8. Well, this is going to be relatively easy to prove because if I said, for instance, angle 1 was 100 degrees this time. Let's do this in pink. 100 degrees. The corresponding angle to this would be 5, which is 100 degrees. And then it creates, once again, the domino effect on the intersection angles. 2 would be 80, 4 would be 100, 3 would be 80, 6 would be 80, 8 would be 100, and then 7 would be 80. So we get this domino effect on the intersections. And when this occurs, then you could prove parallel, then that proves that these lines are parallel. These will never intersect. So the converse is true as well, making this biconditional, right? We could say this, if corresponding angles are congruent if and only if the lines are parallel, and vice versa. You could take this version of it. Parallel lines are, there are parallel lines if and only if corresponding angles are congruent. So all of these can be written as their converse and be true. And that's what this lesson is. So here we have it. If alternate interior angles are congruent, which we clearly see here, alternate interiors 3 and 6, then the lines are parallel. Then parallel lines. So conclusion would be, technically, if you want to put this, you can. This would prove that I is parallel to S. Okay? In every single one of these situations. So here we say if alternate exterior angles are congruent, which they are, for instance, 2 and 7, then parallel lines. Then the lines are parallel. And then with the same sides, if same side interior angles, but this time around are supplementary. So that is the difference. Remember, the converse is, that they're supplementary, so we have to say they're supplementary. Same side interior angles would be 3 and 5. We could clearly see they add up to 180. Then the lines are parallel, or then parallel lines. And last but not least, if same side exterior angles are supplementary, then the lines are parallel. Okay, and we see that here as well when we look at, for instance, same side exterior angles 2 and 8. They add up to 180. Okay, so this also proves that I would be parallel to S. So if we see, for instance, 2 being congruent to 5, right away we could drop these arrows in, but not until then. Okay? All right, so we do see these in proofs. We are going to be proving parallel lines on occasion, or vice versa. We are going to be proving congruent parts of congruent given parallel lines. We're going to be intertwining these. So there is a difference, and it's based off of what is given. If parallel lines versus if corresponding angles are congruent. We have to be able to differentiate it, just kind of like how we do with midpoints, angle bisectors, and so on and so forth. But if you do have any questions, please let me know. And I will see you in the next one. Bye.